Hey guys, it's Simon and welcome to another video about procedural dungeon generation in Kotlin and in using it in LibGDX. So I created a little algorithm for that, which I totally invented myself and didn't look it up somewhere in the internet. And the main method is, as you can see, the generate dungeon. And the way it works is that you specify the dungeon dimensions, which is the width and the height. You specify the critical path length, which means how many rooms will there be from the start room to the end room. Then you can specify optionally start locations. If you don't specify it, then the algorithm simply picks a random location inside the dungeon for the start room. And also optionally, you can specify additional optional branch paths that should be created with a specific length, which is a range, which then picks a random number between the minimum and the maximum length of the path that should be created. So how does that algorithm work? So as mentioned, you specify the dimensions of a dungeon with a width and a height. And as an example, let's take a width of 4 and a height of 4. Then a start location is specified, which in this example will be the bottom left of the dungeon. And the room is highlighted with an S, which indicates that it's the starting room where the player will spawn. Then we specified a critical path length of 5, which means that will be total 5 rooms until we get to the end of the level of the dungeon. In this example, the rooms are spawned to the top, then right, then top again, then left. And if the algorithm would create an invalid room, which would be, for example, outside the boundaries of the dungeon, or if it tries to create a room at a coordinate where there is already a room, then it will go back one step and simply try to generate a room in a different direction. In this example, it tries to create a room to the left, which would be outside of the dungeon. So it removes that room, goes back one step, and then tries the top direction. And with that, it finalizes the critical path, which would be the main path to get from the start room to the end room. In addition, you can specify if there should be optional paths created. And the way it works is that simply every room on the critical path that gets created is a potential candidate for an optional path, a so-called branch candidate. And in this example, let's say we want to have one optional path with a length of 3, and the branch candidate that is chosen is the room with the number 3 of the main path. And then it simply creates another path by going 2 times to the right and 1 times to the bottom, which then also finalizes the optional branch path with a length of 3. With that approach, we already have a randomly generated dungeon by simply modifying the size, the critical path length, the number of optional branches that we want to have, and the length of the optional branches. But the rooms currently are not connected in any way. And the way I wanted to have it is that there are no corridors in between the rooms, so they should be directly adjacent to each other, like in the good old Nintendo times, for example, of a Zelda dungeon. And the algorithm simply, whenever it creates a room after the start room, it always connects the currently created room and the previous room with a so-called door. So going through the example again, step by step, we initially again create the start room. And now when the next room is created with the number 4, it automatically connects the start room and the room with number 4 with 2 doors. And then for every other room that is created, room 3, 2, 1, and the end room, they are all connected with doors directly so that we know that there will be a path from the starting room to the end room. Additionally, when going to the optional branch path, it also does the same thing and automatically connects every room with each other. As a last step, the algorithm then simply goes through all the different rooms and randomly generates additional doors, which would be, in that specific example, that it connects the room number 4 and number 1 with each other. Now coming back to the code, how does it look in Kotlin? So as mentioned, we have the generate dungeon method, which is the main entry point of this algorithm. Then it takes the width and the height, the dimensions of the dungeon itself. It takes the critical path length. All of these are mandatory attributes or parameters that you need to specify. Then we also have the start location, the number of optional branches, and the branch length, which are optional arguments. You don't have to specify them. There are some special sanity checks at the beginning. They don't cover everything, but it's some sanity checks that the parameters that get passed are in somehow valid. So for example, the dimension of the dungeon needs to be bigger than 0. And if you specify number of branches greater 0, then also the branch length in itself must be greater 0. Otherwise, it doesn't make sense. The next part is the start location. So if you specify any list of start locations, then it will pick a random one of that list. Otherwise, it simply picks a random location inside the dungeon. The idea here was that I wasn't sure if my game should have start locations always at the bottom center, left center, right center, or top center of the dungeon. So I left it open. For now, I don't use it, so the algorithm simply picks a random start location. But maybe in the future I could change that it's then always the center of an edge of the dungeon. And finally, we get to the dungeon creation itself, where we go inside the general critical path method, which is the most important one of the algorithm. So the algorithm itself is a recursive algorithm, which means that the generate critical path method calls itself, which I would say in most of the cases is not ideal because it simply increases the stack of your application, and you could get into an out-of-memory exception if there are too many calls of these methods then on the stack. But in my specific case, the size of the dungeons that I create, they simply work, so it's not too much memory consumption in the end. And the way with that specific implementation, it's easier to implement it than doing it with another approach. If for whatever reason that would be a problem, it would need to be changed to not use recursion, or an alternative that I thought, which could also work, is that I simply let that algorithm run before the game starts and simply then save some of the dungeon templates which are created somewhere and then pick one random example of these templates. But for now, it's not a problem. I can create thousands of dungeons with also quite some big sizes, I would say, within seconds. So it's not a big deal. So good enough for that specific use case. So since it's a recursive algorithm, first we check if the length, which is the critical path length initially, is 0, which means that we are done. We have created all the rooms that we wanted to create, and we can simply return true. If the generate critical path method returns false, that means that it couldn't create a room. So for example, the room was created out of the boundaries or was created where a room already existed. And then it simply goes back in this call stack trace of the recursion and tries then a different direction. In general, there are 4 directions how this algorithm creates rooms. There's the up direction, right, left, and down direction. And as you see in the repeat loop, that it tries at most 4 times because there are 4 different directions to create a room. So once we enter the loop, we simply create the index of the next location in the dungeon, which is called here next location. And we check if this location is inside the dungeon boundaries or if there is a room already at that specific index. And if yes, then we already know that is not working, and we try the next direction by simply going counterclockwise or clockwise. That doesn't really matter. It's up to the implementation that you want to use. Then, if the index is allowed and there is no room at that specific location, we create a room there. We add a room to the dungeon at that specific index. We also give the room a specific index, which is simply the current length of the path so that we can also later on identify that room if needed, and we also give the room a specific type. There are 4 room types for me that I needed. There is the starting room, which is the first room in the dungeon where the player spawns. There's an end room, which is the last room of the level, then the player can complete that specific level. Then there are main rooms, which are the main critical path of the dungeon. And there are optional rooms, which are the optional branches rooms. Also, if we are currently creating the main room, so the critical path, then we will remember that specific location where the room was created as a so-called branch candidate, which means that that room is a potential index or location for an optional branch path to start. Finally, we add the doors between the previous room and the currently newly generated room, and then we make the recursion by calling the generate critical path method again. If the method returns false, so a room could not be created, then we need to remove the room, we need to remove that room from the branch candidates, and we also need to remove the doors itself, and then go into a different direction and try again to create a new room. Coming back to the generate dungeon method, we are now done with creating the critical path. The next step is to create optional branches if these arguments are specified. This method is pretty simple because it simply reuses the generate critical path method. And the way it does that, that's simply for the amount of branches that should be created, it goes through that in a loop. So if there are still branch candidates left where we can try to create branches, it will pick a random one. Then it will also pick a random length of the branch length that was specified to the generate dungeon method. And once we have this information, it then calls the generate critical path method. But this time, instead of creating main room types, we create optional room types. The last step now of the algorithm is to create additional extra doors, which is the generate doors method. So this method simply takes all the rooms which are available in the dungeon and then picks random ones from the main and optional rooms. The start room and the end rooms are excluded. And if a room already has 4 doors, so there is a door in each of the directions, then we cannot create additional doors anymore because all of those are already spawned. So we cannot pick that room and we will go to the next one. Otherwise, from that specific room, we get all the surrounding rooms in the different directions. Check if it's not a start or an end room. And if there is no door already in that specific direction. And then for every potential surrounding room which could be reached with a specific percentage, it's random again, we could then create a door between those 2 rooms and connect them. Running this method now 1,000 times for a dungeon with a dimension of 8 by 8, a critical path length of 12, optional branches of 6, and a length between 3 and 5, takes less than a second and creates those dungeons here. We have here a start room, then we have the main path, which at some point goes to the end room, and in addition we have some optional paths that spawn from the main path. The dots highlight the doors, so how the rooms are connected. S is a starting room, E is an end room, M is the main critical path, and O is the optional branches. And here are some other examples. The way I use it in LibGDX is that I implemented a so-called dungeon loader so that the dungeons are handled by the asset manager, because the dungeon in itself is then a list of tiled maps and the tiled maps can repeat itself, because my idea was that I simply have dungeons with a specific tile set. So for example, a grass tile set, a fire tile set, maybe a darker tile set, depending on in which level of the dungeon you are. And then for each tile set, there will be different rooms. Like you can see here for the default tile set, I have currently 3 example rooms, 1, 2, and 3. And now when we load a dungeon with the default tile set, it will use the algorithm that we saw before. And the rooms, so the S, M, O, and E rooms, they are then simply replaced by a random room of this default tile set currently. So if we now start the game, we see that the algorithm created that dungeon here with that specific layout. And in LibGDX, we simply have then different tiled maps, and the debug system that they currently use there is that the starting room is in green color, the end room is in red color, optional paths are in yellow colors, and the main path is with just the normal color of the tiled map. And as you see, the dungeons itself or the rooms themselves, they are always different. So currently I just have 3 different rooms, but they are randomly chosen. And also the doors are automatically created already on different areas on the edge. And the player could already move from room to room, but the implementation there is not yet final and will change a little bit. So I don't want to show that yet. And just to give you an example in tiled, how does that look like? So this is one of the rooms, how they are currently created. And there is a doors layer. In this doors layer, you can see here there is a up area or up objects, then right objects, down objects, and left objects. And the algorithm then, when we know that there should be a door on the upside from that room, then it takes all the objects that we have here. Then it picks a random location in all these objects here, in all these rectangles, and randomly places a door somewhere to spawn then a door that moves the player upwards. So it could be, for example, here. The same would be for the right, left, and down direction. Additionally, there is a spawn layer. So if this is the first room of the dungeon, the starting room, then the player would spawn at that specific area. What is currently missing is then also enemies and traps and so on. But as mentioned, this is early in the development, and currently I was just focusing on the dungeon generation. So that's it. Thanks for watching. Have a nice rest of the day, and bye-bye.